In this video, I'm going to build an end-to-end data pipeline using time series data and with the time series database. We're going to take weather data from a weather API, process it on AWS, and then put it into a time series database and visualize it with Grafana as a dashboard. So let's get into it. Before we start, I created a GitHub repo for this project with everything in it that you need. So check out the repo. I have the link below in the description of this video. There you're going to find the setup of this. You are going to find a step-by-step guide with commands that you need to execute. And if you watch this video to the end, then this will be absolutely no problem. I also put here helpful links that you could need and more a bit about TDengine. So let's get into the setup. All right, here's how this project is set up and what we're going to do. There are a few parts here. On the left here, we have our IoT, our Internet of Things part, where we have our weather station, which is the IoT device that measures the wind and the temperature, and that sends the data somewhere. We don't own these devices, right? So these are going to send the data to the weather API that is hosted on weatherapi.com. It's an open API, free to use. Very good. Then we have our part where we are going to host all the processing. The processing is going to be done on AWS. So the main part here is the Lambda function that will then query the data from our weather API and write it into TDengine, a time series database. It's, by the way, the sponsor of today's video. TDengine, a open source high performance solution for time series data. They have it as a Docker container, but also as a cloud service. And I'm going to use the cloud service here, which is quite new. Then from this point on, we're going to use Grafana, which is a dashboarding solution very often used. And Grafana is going to then access TDengine and it's going to display us the data, the measurements from our weather stations. And here on the right side, that's a user, that's us. To develop this, what we're going to do is we're going to, here on the top, we're going to have our development environment, local environment, your computer, or my computer. We have I have here VS Code, I have Python installed, I have Docker installed. These are the few parts, and I'm accessing the weather API. Once I've done the testing on this, all we need to do to actually then deploy this is we are creating a Docker image, and this image we're actually uploading into Amazon ECR, Elastic Container Registry. The registry is then hosting that image of our program. What we're doing is we're telling the Lambda function to use that Docker image that we're hosting at the ECR. So this way, whenever we develop something new, we can simply re-upload it, the updated image to the ECR and tell the Lambda to use the new version, and then that's it. How do we schedule this? Of course, just like always, we're going to use EventBridge here. Very simple service. EventBridge is then going to every 10 minutes call the Lambda function, and this way we basically get this end-to-end part. We have our weather data that's coming into the weather API, goes through the Lambda function, gets put into TDengine, then into Grafana, and on the end here we are sitting and we're watching it. But before we start, let's quickly look into time series data. What is actually time series data? The idea with time series data is that the main factor in it is always the time, because we have a measurement like our temperature, and that measurement has a distinct time and a value. And from a time series, then you can build, for instance, charts like these, where you have the time and you have the weather data or the temperature in degrees Celsius or in Fahrenheit. Right? This is for two different locations. The green one is for Berlin and the yellow one is for San Francisco. Now you might think, okay, why a time series database? Here's the difference between a time series database and a relational database. When you look at the different databases, a usual relational database here on the left, the main thing is, how do you use relational databases? You have relations, you have primary and foreign keys. And whenever you look into tables, a table usually has an ID field with an integer. Because this way you can just, whenever something new comes in, you can iterate over the ID and basically increase the ID by 1 and then create relationships. Then your location data would be a variable, just a character string. And then you would have your temperatures and your wind, and you would have the timestamp here as another column, just a column within this whole thing. So, right, the important part is here is the ID, here's the index, and here is the timestamp. So the timestamp is just another column in this. Whenever you then look into time series databases, like here on the right, the leading factor or the leading thing here is always the timestamp. The timestamp is the most important thing, is always indexed, and these things have special functions for the timestamps. If you have location, you would add something like a tag, and then you have your actual measurements here. Usually a time series database doesn't have any relationships. It's just, okay, I have the time is needed for every data point, and then I have my measurements for the data points, and maybe a few tags additionally to it. Now, this is nice, but why exactly? What do time series databases deliver that relational databases cannot do? The main thing here is speed. They are optimized for speed because they're very simple, right? You have the timestamp, you have the values, and this is all it needs to do. So it's optimized for storing the data quickly and returning you the data very quickly. Retrieval, speed. It's also good for scaling because there are no super difficult relationships between the data. You have your device, and that device is going to send you data. And then it's easy to distribute the devices, for instance, or horizontally over a certain amount of machines, right? So the scaling is very easy. It also offers you data retention automatically. Whenever you get IoT data, usually you have a lot of data coming in, and you don't always want to keep all that data. Very often, after some time, you don't need the data anymore. So you are going to use data retention, where you say, okay, I'm going to keep the data for 12 months. Or for 6 months, and after that, the database is automatically going to delete the data from the database. Then you have something like rollup, where you aggregate over data, where you use time windowing, which is with the normal data relational database very difficult. With these, everything built in. So very nice. Some databases like TDengine can also do interpolation, which actually then creates you data points where there is no data point. Pretty clever, because you have the time, right? And if you have the interval and there's a missing data point, it can figure out, okay, this should most likely be the data point. And then also you have like time series extensions where you do something like weighted averages or rate of change in a time window, stuff like processing of the time series data that you usually would do externally, but these time series databases actually can do that internally. Now let's quickly talk about TDengine adoption. It's very interesting. They are just coming up. The red line here is TDengine. The adoption is rising very quickly. They already left Amazon TimeStream below there. They also surpassed OpenTSDB, which is a big one. And they're going to attack sooner or later TimescaleDB. TDengine, very interesting solution, very on the rise right now. Also, let's quickly talk about external data sources. Usually with relational databases, you need a certain processing before it, and then you can put the data into your database, right? So you need to extract it somewhere, transform it, and then load it into your database. With time series databases, for instance, with TDengine, the cool thing is a lot of stuff is already built in. With TDengine, for instance, you can have, if you want to do monitoring of equipment, for instance, Telegraph, Prometheus, these tools already have connectors to TDengine. So you can if you have them running, they can very easily send the data directly into TDengine. Then especially for IoT use cases, Very often you use MQTT, which is a message broker, a message queue that actually can directly send data into TDengine. Also, industrial buses like OPC-UA, OPC-DA can send data directly to TDengine, and Kafka, that's a big plus compared to relational databases. These time series databases are meant for directly using sources to get the data in. Of course, you then have your typical visualization tools like Google Data Studio, Power BI, Tableau, or Grafana that we're going to use in this project. All right, let's get back into the project now that you know time series databases, now that you understand why time series databases make sense. Let's set up this project. I already did this, but we're going to go step by step here, and we're going to see how exactly I have set this up. Again, for all the links and to do this, go into the GitHub, scroll down here, and we're going to now do all these steps. So let's start first with our API. All right, so what you need to do, go to weatherapi.com, create yourself a user, and then in the user interface here, use the API key that you get. You can also here generate a new one. I'm just using this, and then this we need for our piece of code to actually get the data from the API. What you can also do is you can use the API Explorer here, go to the Explorer, put your key in there, and then, for instance, we can, let's generate this for London. And then we see our response headers and we see our response body, which is a JSON. For us, what we do is here, we are going to take this current part. We're going to use the last updated. We're going to use temp C, temp F, and wind miles per hour and wind kph. As you can see, there's also pressure and fields like and other stuff. We're going to do this for San Francisco and for Berlin. How this works is super simple. For that, let's quickly go into our code. In our folder for our code, there is a source folder, and the source folder actually has the JSON writer JSON that we need. And in this, the function getWeather, that is the function that actually gets us the weather data and then later writes the weather to TDengine. Here, to get the data from the API, first of all, we are going to use here requests, right? The requests library. And we're going to here in our payload, we're going to use the key. We're going to use here our location. The location we're going to give this in here. AQI, I actually don't remember what this is. We could now check the documentation, then we would know this. Then we are going to make a request here. Request, this is our weather API. This is the weather API v1 current JSON. And we're going to here our payload put in the parameters. This will then deliver us what we've just seen. Then here is also this parameter, get air quality data. What did we say? Yes, we actually would not need this. This will then deliver us our response body. And again, from that response body, first of all, we're going to take the JSON from the response body, and then we're only going to take the current part out of it. Here comes the trick a bit. The data, when we look at the time series, the time in the request is actually formatted like this. It's formatted year, month, and then day. And then there's a white space, hour, minute, second, and so on. But actually TDengine has to work with the standard ISO format where there is here, actually there is a T here in between the date and the time, and there's a C for the Zulu time at the end. So all we need to do here, first we need to use date time here. We're going to use date time, and our last updated, we're actually going to read the string and format it. And this is the format of the string, and create a date time object. And then from the date time object, we're going to create a string again. And this string we're going to format in the way that we actually need it. That's basically it. And then we're going to write this into the weather API. Actually, we can do a quick print here, print current, and then let's run this quickly. So this is how this is going to look. This is our string that we get. And this here's the last updated replaced by the new timestamp and all the other additional stuff. All right, so now that we have the data, we actually need to create something where we put it in. And we're going to do this in TDengine. So let's go over to TDengine. So here's the UI of TDengine. What I have done is basically you can log in. They have a month free for you where you can use it. First of all, you create an instance. My instance is here running. It's a starter instance. The important part here is the token and the URL, because we are going to need this in a sec for our configuration in the source code. And then we need to actually set up the database. So what we do is we go to Explorer, and I created here just with that, I created a database and I called this weather. Now here's already the important part. We talked about this before. You can set here keep. This is the upper limit. So this data will not get deleted very quickly, but you could set here 5 days, 6 months or something. The data will be deleted out of it. You can set the precision here. Do I have milliseconds, microseconds, or nanoseconds, which is a big deal. And the duration of when the data will be written into another file on disk. So after a certain amount of days, this data will get into a different storage. Then we have write ahead log stuff. We don't need that to talk about this now. And also we can cache data here. We can cache data so that once the data is written, it doesn't need to go to disk to query it. It can read the data out of the cache. So I create the weather data, and then you create S tables. And the idea with S tables is in the S table, let's see our S table configuration. We have our timestamp here. This is needed. This is the first thing. This is last updated. This comes from our request. Then we have our values, all double. And then here is our location as a varchar. This will be, here will be Berlin, will be San Francisco, for instance. Then what you do is you can just here add another table, give it a name. So if we would have Buenos Aires here, we would just give it Buenos Aires, the name, and the tag, we would add the tag value Buenos Aires, and that's it. Boom, done. If you have 1 million devices, this will generate 1 million tables here, because again, there is no relationship between these. There are no primary and foreign keys, so it's easy to distribute. It's also easy, very easy to access this data. That's all that you need. You can get data in. Again, you could upload here with CSV files or with the collection agents. If you have Prometheus or Telegraph running visualizations, you can use here Grafana or Data Studio. For our connection, if you want to connect, you can use programming here, Python, and here's actually how to set this up. So we just need to use TAOS REST here, and we create a connection. And that's all that we do. We go here to our code, TAOS REST, and then here we do a open connection and open con TAOS REST connect, and we use the URL. That's the URL that I've shown you from the instance, and that's the token from the instance. Pretty simple. And then this opens the connection, and we can also do a connection close. And for the writing, it's super simple. If you want to write this, I created a function here, write weather, which gets the location and our JSON string and the connection. All this does is, first of all, we replace the white spaces, right? Because in San Francisco would be a white space, but our table name, they need to be without white spaces. So we need to remove all the white spaces, and then we just say, okay, let's take our no white space location, insert into weather dot Berlin, weather dot San Francisco, and then the values, and then here are our values. Last updated, temp C, temp F for Fahrenheit, wind miles per hour, wind kph. That's it. And then we're going to write this here in our function get weather. I actually directly called the writer. I was thinking, should I do this differently? But I was calling the writer directly here, and then this writes into TDengine. And once we do this for Berlin and San Francisco, we close the connection, and that's it. Now that we're here, what we actually can do is, for instance, here we can look. This is our configuration, of course, for the table, and this is our weather data. So we already have weather data in. I already let this run since yesterday, so then we have some data to actually show. If you want to use the test database, they also have a test database with meters that you can explore. So with that, we have our data in our time series database. What should we do next? Let's get back to this chart. The code for the weather API, this code we have. The TDengine part, we also have. Grafana, we don't have yet. And this whole part here, we also don't have. This is what we need to do next. What I created for you in our folder of our project, I have here a Docker file user and I have a requirements.txt. Requirements.txt is going to be the libraries that need to be installed when we build our container image, and the Docker file user, this is going to then basically help build this project. So we're copying the requirements, then we run pip installs, we're copying our writer_JSON file into the image, and then we say, okay, our entry point is going to be the writer.json py, so it's automatically going to execute our code. And that's all that we need for building this. Then we open up our console and we actually then build our image. And all you need to do here is you need to go into your folder where you are, where the source files are, docker build -f docker file user, because we want to use our specific Docker file, -t, the weather data. This is going to be how the image is going to be named, and the dot here is very important. And we execute this. Unfortunately, this is blue on blue. It's going to be loading everything, and it's going to be copying and installing everything. I already did this. That's why it was this quick. And with that, we can just say here, docker run weather data, and we can run our weather data. It's not going to give us a lot. No, it's going to give us this print output here. This is because we activated the print earlier. So we know it got the data, and it most likely also wrote it. But with that, our image is ready. So let's do everything on AWS that we need to do. All right, to upload the image, what you need to do is you need to go to your AWS console, go to Elastic Container Registry, and then just click here, create repository, and then make it private or public, whatever you want, and add your name here. I called this weather data because I called also the image weather data. So use the same name, and then here's the weather data and your image. When you start, this is going to be empty. On the top right here, here on the top right is view the push commands. And with these, you can then push your image to the cloud. These only work with the AWS CLI. So check out here what to do in the right order. Create a user and create the keys, the secret key and the access key for the user, and then do a AWS configure after you install the CLI with this link here. And then you can just, I'm not going to do this again. You can just say, okay, first log in, then we're going to do a Docker build, what we've already done. And then we are going to tag this first so that your image is tagged in the right way for ECR. And then you're going to do a Docker push and push it into ECR. And once it's there, you can see it like this. So I pushed this twice. So I have two versions, and the latest version here is the one from today. With that, your image is uploaded. Now we need to actually activate this. We need to do this part here. This part, now our image is up. We need to do this part where we say, okay, Lambda function use this image. And that is pretty simple. All you do is you go to Lambda. I already created the function, but you can also do create function here. You select container image, you give the function a name, and then either you get the URI from the image or you say browse images, and then you select your repository and you use the latest and then select image. It's not really a big deal. There's this, and then you say create function, and then it's going to create you the function. And that's what I had here, my weather. This is how this function basically looks. Your image is going to stay here. That's my image URI that I had. Let's go back to this. With that, we developed everything locally. We uploaded it to ECR. We created our Lambda function. We used it, right? We used the image. Now we need to schedule it. That's all. So for that, we go to EventBridge, Amazon EventBridge. And what we do is we create here schedule. I already created a schedule for this. This is my weather trigger. Just edit this. Edit. So here, you give the schedule a name. You make a quick description. You don't need a group. Do a recurring schedule, rate-based schedule, and then you say every 10 minutes it's going to run. You can also use cron here, where you do a cron expression. Flexible time window I set off, time zone, and that's it. You use frequently used APIs, invoke Lambda, exactly, invoke, and then your Lambda function, you can select your Lambda function here, right? Select the Lambda function, go next, enable the schedule. Permissions you need to create, do a simple create new role for this schedule, and then do the next, and that's it. And then save it. And with that, your schedule is running. It says here enabled, and your Lambda function is running. So all you need to do from this point on, you need to go to your TDengine, and you need to wait for new data to come in. Weather, Berlin, order by last updated, descending. And here's our weather data. Just updated 7 minutes ago. If you're curious, does my Lambda function actually run? Go to Cloudwatch, then in Cloudwatch here, go to logs, log groups, and then within log groups, you're going to see your Lambda function, my weather, and here you are going to see, okay, this run here, 7 minutes ago, and this is running every 10 minutes. With that, what is left? Let's quickly go back to our overview here. So we now have our Lambda function, it's scheduled, it's uploaded, we get the weather data, we put it into TDengine. All we need to do is just set up our dashboard. And that's also very simple. We are going to set up a Grafana dashboard. All you need to do is use the GitHub, go do a Docker pull Grafana, which is the dashboard, an image, a Docker image, and then you do a Docker run name Grafana with the ports 3000 to 3000, so it's going to map it, and then Grafana, the actual image. This is going to run. I already started this before, so what I'm going to do is the Docker start Grafana, and then I just do a localhost 3000, and I'm here at Grafana. First of all, you need to go to connections, add a new connection. You do here TDengine data source. Create a TDengine data source. The configuration of it is very simple. Use the host, that is the one from within TDengine, right, from the instance. Put the host in here, user and password you can add, and use your cloud token. Same as for the Python code. Put this in here, do a save and test, and then it works. Then create a dashboard, create a new dashboard. I already created a weather dashboard here. You can just say here, plus new dashboard, and then within here, you can add a visualization. And then do an edit. And in this, you could say here, let's select not the last 5, let's select the last 12 hours or 24 hours here. And all I did was here, I added, let me make this a bit smaller. I added a few time series here, A and B, and A, I did select last updated time in C from the weather in Berlin. This then is the A, the green one, and I did the same thing for San Francisco, weather.San Francisco. Basically, I accessed the table, and then this automatically is going to call our data and view us the tables here, the charts. Pretty straightforward. Now this is going to update and it's going to visualize us and everything done, right? So if we look at this, Grafana now is also done. The thing is, I hosted this locally. We could also host this in, for instance, AWS Fargate, but then we would need to work with IP addresses and so on and external access. I just wanted to set this up that we host this locally on our machine. And with that, everything is done. If you want to check this out, if you want to replicate this in the GitHub, I have all the code and all the steps you need to take. It's pretty straightforward. Just clone this and work with this. Here are all the additional links, more about TDengine, again, sponsor of this video. And yeah, I hope you had fun with this video. Let me know in the comments what you think. Again, check out in the description the GitHub, check out TDengine, and if you want to learn data engineering, check out learndataengineering.com. See you next time.